Hi, it's a guy Holumde, and today we are gonna be solving another one of the most commonly asked tech interview question by top tech companies including Google, Amazon, Netflix, Spotify, Meta, Microsoft, and other top tech companies. Today we'll be considering the valid parenthesis expression. The problem statement states that given a string representing an expression of parentheses containing this character here, this opening parenthesis, this closing parenthesis, this opening square bracket, which is also a parenthesis, this closing square bracket, this opening curly bracket, and this closing curly bracket. So they are generally called parentheses. So we want to determine if the expression forms a valid sequence of parentheses. So we are going to be given an expression is like a string, and this string will contain these particular characters highlighted there, and want to determine whether true or false if the expression forms a valid sequence of parentheses. And the sequence of parentheses is valid if every opening parenthesis has a corresponding closing parenthesis and no closing parenthesis appear before its matching opening parenthesis. So considering this example right here, we see that this is a valid parenthesis expression because we see that every opening parenthesis is accompanied by its corresponding closing parenthesis. Look at this square bracket inside there, it's accompanied by its closing parenthesis. Same thing as this curly bracket accompanied by its closing parenthesis, and the same thing as the enclosing parenthesis, which is this one that is outside, that is enclosing the inner one. It comes in the right, they all come in the right order. So and that's how we return true here. But considering this second example here, whereby fine, these two square brackets actually correspond to each other, but if you look at it, the opening curly brace is not followed by a corresponding closing curly braces, and it is actually followed by this parenthesis instead, this closing parenthesis, and because of that it is not valid. So in the explanation here, we see that this opening parenthesis is closed before its nested curly braces. Like you can see here, fine, we know that this particular parenthesis is opened in the first string, but it closes before before the curly braces closes. Or we can put it in another way that the closing parenthesis for this curly braces is supposed to come first before the closing parenthesis for the enclosing this enclosing parenthesis here. So yeah, an early observation that we can see from this example given is that for each type of parenthesis, this particular brackets and this square bracket and this curly brackets, for any type of parenthesis inside the string that is given to us, inside the expression, an opening parenthesis need to be accompanied by a closing parenthesis. So they need to be the same number of opening and closing parentheses before the expression is valid. Look at this first example now. We see that there is one opening parenthesis, and then it is accompanied by one closing parenthesis, one opening square bracket also accompanied by. So each opening parenthesis has to have its corresponding closing parenthesis. So meaning that there must be an equal number of opening and closing parentheses. But this observation actually is not enough to validate this expression. Let us consider this example here. We can see that in this example, here we have the same number of opening and closing parentheses. Look at this opening parenthesis followed by closing parenthesis. At least those cancel out, 1. So look at this also, a closing parenthesis followed by an opening parenthesis. So we have the same number of opening parentheses and closing parentheses, but still this expression is invalid. Why? Because of their order. They are not in the right order. So we need to find a way to account for the order in a parenthesis, not just the number of opening and closing parentheses, but also the order. Now let us consider this example here, this string expression. Now we see that the first parenthesis is opening, and then we are waiting for this parenthesis to be closed. That this is it right here. the first is opening, and when we get to the second one, I mean the second element in the string, it closes the first parenthesis. So we can conclude that this is valid. Now let us consider this string here. So by the time we get to the first parenthesis, the first index in the string, by the time we get to the first index in the string, we have this particular parenthesis, which is the square bracket. Now when we get to the second index in the string, we have another opening bracket. So but when we get to the third one, which is the index 2, index is 0 base. When you get to the third index now, we actually found a closing parenthesis, but we are actually expecting a closing parenthesis for this particular opening parenthesis. So and we come across a closing parenthesis just like here, and it does not close the most recent parenthesis. Why? Because fine, we first touch the first index and we have an opening parenthesis, and then when we go to the second index we find another opening parenthesis. So this is the most recent opening parenthesis, and we expect it to close before this the least recent opening parenthesis. So but when we come to the third index, it is closed by the least recent instead of the most recent that we are expecting, and so it is not valid. So one observation we can have here is that the most recent parenthesis that we encountered is the one that should be closed first before any other parenthesis that come before it. So like in this case now, this is the most recent parenthesis here, though we have one before it, but we now come across and encounter a new parenthesis which makes this the most recent parenthesis, so it has to be closed first before the least recent parenthesis. That's one observation we have from this example. So opening parentheses are processed from the most recent to the least recent, meaning that the last in first out approach, last in first out dynamic, meaning that fine, from this example we see that this square bracket is the first in, followed by this parenthesis here is the last in. So now the last in need to be the first out, and that approach is what we are going to be using in solving this problem. And this leads to the idea that stack can be used, because stack is based on the last in first out technique and approach. Now this is a strategy that we'll be using to solve this problem, a simple strategy, and it is that we are going to add each opening parenthesis. So as we encounter them, we are going to be adding them to the stack, and this way the most recent parenthesis will always be at the top of the stack because it is the last in. So the most recent, which is the last one, will always be at the top of the stack. And then when we encounter a closing parenthesis, don't forget we are adding each opening parenthesis. So when we encounter a closing parenthesis, we want to check if it can be closed by the most recent, that is the parenthesis at the top of the stack. You understand, the most recent parenthesis. If it can close it, then we pop off the top of the stack. So popping off the top of the stack means that fine, we can close it. So that opening and closing now is the deal is done on that. So we are gonna pop out of the stack so that we can get to the next top of the stack. When we pop that most recent parenthesis from the top of the stack, we will get to another another parenthesis that follows that particular parenthesis at the top of the stack, and we can use it to attest and to check for the next closing parenthesis in the expression. So but in a situation whereby it does not close this in a situation whereby it does not match or it does not close the most recent opening parenthesis in the stack, meaning that the closing parenthesis that we encounter in the expression, in the parenthesis expression, if the closing parenthesis does not if it does not correspond and it does not close the most recent opening parenthesis on the stack, definitely it is an invalid string. So just like in this case now, okay, let's go through an example now. Let's consider this example here. So we see we have this a string expression that contains parentheses, and then we iterate through the string first on the first index, And what we do is that because we are encountering an open parenthesis, we're gonna push it into the stack. Now we encounter another open parenthesis by moving our we are iterating through the string now, parenthesis expression. So moving to the next element now, it is another opening parenthesis. So what we do is that we push it to the stack again. So just like you can have it right here. So, and don't forget that now this new one, this the most recent parenthesis is going to be at the top of the stack, just like it is in this visual. Then we navigate to the third element in the expression, and then what we encounter is a closing parenthesis. So what I want to do is that I want to check the top of the stack here and to see if this the opening parenthesis at the top of the stack, if it closes this parenthesis, this closing parenthesis that we encounter in the expression, because it closes it, this because you see this opening parenthesis at the top of the stack closes the closing parenthesis that we encounter in the expression, we are gonna pop out the last, I mean the top of from the top of the stack, which means that the most recent most recent parenthesis that is at the top of the stack, we are gonna pop it out. Why I'm popping it out is because fine, we are gonna be moving our iterating through the array, we're gonna be moving our I to the next index, and so we want to make sure that we at the top of the stack is referencing the next parenthesis that is to be closed. So we want to pop that one off. So, and when we move our array to the next element in the expression, we see that, I mean, when we move our index, our variable I, is iterating through the expression. So when we move it to the next index, we come across a curly parenthesis, a curly bracket now. So, but because it is an opening parenthesis, what we do is that we push it again to the top of the stack. So, and then after doing that, we iterate through to the next index, and then the next step is this closing parenthesis. Now you will see that this closing parenthesis does not correspond to the parenthesis at the top of the stack. It has to be closed by the most frequent, not most frequent, but the most encountered, I mean the most recent parentheses that have been encountered, and the most recent is this. If you look at the previous index that we were before we get to this one, so this is the most recent, and because it is not closing it, look, the curly braces is not closed by this one, and therefore we're gonna return false. That means the parenthesis is not valid. So that's how we're gonna be solving this problem. So, but we want to look into an edge case now. So don't forget how we'll be solving this problem, that we're iterating through each element in the parenthesis expression in the string. So, and whenever we come across an opening parenthesis, we add it to the top of the stack. Whenever we come across a closing parenthesis, we are gonna check if the parenthesis at the top of the stack closes that closing parenthesis that we come across or that we encounter while iterating. If we do, we are gonna pop it out of the stack. If we do not, we are gonna return false, because that means they do not correspond. Now we are gonna be considering an edge case now. An edge case, look at this expression now. Fine, we can say quickly that this is a valid, it's really a valid parenthesis expression. Why? Because first of all, we push this opening parenthesis, and when we come across here, we pop it out. So one thing you will have to do at the end of the day is that we need to ensure that the stack is empty. Why? That's what made the balance. That's what make up the balance, that every opening parenthesis that have been added to the stack have been popped out because we encountered their corresponding closing parenthesis. So the stack needs to be empty, but we have an edge case here whereby the stack is not empty. So it's an edge case. Why? Because fine, we pushed at the very first element, we are gonna push the opening parenthesis into the stack, and when we come across here, we're gonna pop it. Fine, but looking at this now, we are gonna push again because we come across the third element, which is an opening parenthesis. We're gonna push it into the stack again, but in that situation now, we loop out, right, without returning an error. Don't forget, an error is, so far we said that an error is going to be returned whenever the top of the stack is not the top of the stack is not closing the closing parenthesis that we encountered in the iteration. But in this situation like this now, we see that fine, we're not going to have any false returned. Why? Because this is actually a closing an open parenthesis, and we added it to the stack, so no error occurred. So, and that's the reason why we need to check at the end of the whole iteration to check whether the stack is empty or not. So look at this situation, this scenario now, the stack is empty. Why? Because every opening parenthesis is adequately closed by a closing parenthesis. But this situation now, we still have a opening parenthesis inside the stack that is not closed, therefore it is not a valid expression. So after following the principle that the logic that I explained earlier, the logic of iterating through the expression, adding every opening parenthesis to the stack, and trying to check if whenever we encounter a closing parenthesis, trying to check if it closes the opening parenthesis at the top of the stack. If it does, move on, pop out of the stack. If it does not, return false. After doing that, you then check if your stack is empty. If it is not, definitely it is invalid. So, and another one is, how do we manage this type of parentheses? Because really in the problem statement actually told us that we are having a set of characters, so we won't just be given this particular parenthesis alone. We'll be given in like three set of parentheses, or three set of opening and closing parentheses. This type, the other, the square bracket, and the curly bracket. So how do we manage them now? So we're managing them using a hash map. So a hash map whereby this will be the key and this will be the corresponding value. So it means that this is the opening parenthesis, and this is its corresponding closing parenthesis. So whenever we come across a closing parenthesis now, we can use an hash map. So the reference opening and closing parenthesis like this, like you can see here, we can use it to reference that it is the one that is at the top of the stack, so that we know whether to move on or to return false. So this is how we manage the three type of parentheses. And so we'll be going to the code logic right now. Alright, let's go into the code implementation. We'll be defining a function as the valid parenthesis expression, and we'll be collecting the string, the parenthesis expression as s. We'll be returning a boolean, so that will tell us if it is a valid parenthesis expression or not. So, and then this is particularly the string here. So we can even call the function as expression of x. Alright, so now let's go into the implementation. Let's define our parenthesis as so we'll be using a hash map now. So we'll be having this brace this parenthesis followed by its corresponding closing parenthesis, just like we defined in the logic. We'll be having this as well, followed by its closing brace, and we'll be having, so this is how we can track which closing parenthesis corresponds to which opening parenthesis. So we can have this as well. So alright, we can also define our stack. We'll be using a list for our stack. So it's just a stack is just any object, like a list that follow the last in first out principle. So that's stack. So right now we'll be iterating through our each character, each parenthesis in s. So why? According to logic, we have to iterate through them. And now if the parenthesis is an opening one, we want to add it into our stack. So and now we can get that is if c is in parenthesis. So if c is, that is if it is any of these keys here, they want to add it to a stack dot append So we are still using a list, but we will be using the functionality of a stack, last in first out. That's why you are seeing append. It's actually a list, but we are not just indexing, we are not just removing, we are actually adding and popping. This append now is a way of pushing. So if we perform a pop now, is a way of popping and removing from the last. So alright, so in a situation whereby it is not in the parenthesis, that is, it is not a key in this parenthesis hash map, definitely is going to be a closing parenthesis. I hope you understand. So we are iterating through our string of parentheses now. So if it is not an opening parenthesis, definitely it's going to be a closing parenthesis. And in a situation like that, we want to check if it corresponds to the last or to the top of the stack. So, and what we're gonna do is that we are gonna check if parentheses of stack of -1 if it's equals to C. So you might be wondering that why do I do this? What I'm trying to do is that we try to go and get the last element in the stack, which means that the top of the stack, it means the most recent parenthesis. So don't forget that in a list we used to use -1 to reference the recent, the last index, the most recent insertion or append. So, and that's what we're trying to do here. We're going to get the most recent parenthesis, and then don't forget that inside the stack will always contain opening parenthesis. So we now try to go and check their corresponding closing parenthesis inside this parenthesis hash map. So we're now trying to compare it with C. If C, C is gonna be a closing parenthesis now. If it is not an opening parenthesis, it's gonna be a closing parenthesis under this else statement. And now if the stack, if the top of the stack contains an opening parenthesis that closes this parenthesis, then what we want to do is that we want to pop out of the stack. So dot pop. So just pop out of the stack so that we can remove that opening parenthesis away from the stack. It has closes the closing parenthesis that we encounter while iterating through S. So we want to pop out of the stack and move on to the next elements or the next parenthesis in the string. So but in a situation whereby it doesn't pop out, then what I want to do is that I want to return false. Why? Because if the element at the top of the stack, parenthesis at the top of the stack, does not closes this closing parenthesis C, definitely it is not valid. So, and if we can iterate through everything right here, without returning false, then we want to return not stack. Okay, why are we returning not stack? We are returning not stack because we want to confirm if stack is empty. So if stack is empty, it's gonna be true. Stack is gonna be true. So not stack is gonna evaluate stack is gonna be false. So not stack is gonna evaluate true. So mean that we're gonna be returning true. But in a situation whereby there's still an opening parenthesis inside our stack, definitely is gonna return false. So don't forget that if there's an element inside the stack, in Python, if there's an element inside the list, is gonna be true, and not true is gonna return false. But if there's no element, it's gonna be false, and not false is gonna return true. So it's just a way to ensure that the stack is empty so we can return true. So just to keep things for exception handling, we are gonna say if stack and, so we don't run out of index here. So don't forget that we are trying to get the last element, so we must ensure that the stack has at least one element. So now we can run the code now and see how it goes. Alright, we have true returned here, so which is correct. So that's actually how we go on solving this problem, the logic and the code implementation. So I want you also to go through it, and I hope you understand. Don't forget to like, to comment, to share, to subscribe to our channels, and expect more. Thank you.